Okay, so hello, good afternoon, everybody, or good morning, I guess, depending on where you are. Thanks for joining the webinar today. My name is John Tinsley. I'm the director and co-founder of Iconic Translation Machines. In case you're not already aware, we're a machine translation technology provider based in Dublin, Ireland. We've been in business now for a little over a year, although our technology has been in development for a good while longer. In fact, the company actually originated from the CNGL Research Centre in Dublin City University, from where we spun out, and still actually retain close links in terms of our ongoing research and development activities. So in terms of today's webinar, just let me start with a brief overview of what we're going to cover today. I guess starting off, what we do is obvious, but of course, let's go into a little bit more specific detail about that, about our particular approach to machine translation, which is something that's not quite what has been done before. I'll talk a little bit about the process involved in developing these MT systems and what the benefits are for the users of these types of MT systems, which goes beyond simply translation quality. Then I'll talk a little bit about how Iconic Translation Machines can be accessed specifically and the various use cases where it's applicable. Then we'll take a look at some specific examples of things in action through some client case studies, and then a look at our future plans for Iconic and developing machine translation systems. And then finally, I'll conclude with some take-home messages and some lessons that we've learned. So I plan to go through this with you in around 30 minutes, after which we can do some Q&A if there are any questions. I think if you have any questions that arise, you can type them into the chat box here, and then I'll revisit them at the end. So I guess to begin with, there are three high-level topics that I'll cover in the webinar, which I'm going to introduce to you first and then go back over as we go through the presentation. So firstly, our technology. What exactly do we do? So we provide machine translation with subject matter expertise. That's machine translation that has been designed for a very specific combination of language and content types. Because I think as a developer of machine translation technology, you can't be dogmatic when it comes to your approach to MT. A question we always get asked naturally is, what type of machine translation do you have? And I think it was a tricky question for us to answer, because if you're familiar with the different types of machine translation, we're not strictly a statistical machine translation vendor. We don't focus on tools like Moses, but we're not a rule-based MT vendor, and we don't do hybrid machine translation. The answer is that we actually do all of them. Sometimes we use them all at the same time. Sometimes we only use one. It's completely dependent on what works best for a given content type, style, and language paired together. And we call this approach an ensemble architecture for machine translation. So for example, if you're doing Chinese, English, pharmaceutical machine translation, maybe a statistical machine translation system with some rules for post-editing is best, but maybe for Japanese English, some rules is best, or maybe for French English, where the languages are a bit more similar, a statistical machine translation system will be sufficient. So what we do is we actually study what works best for each language and content type, and we build an ensemble configuration for that language and implement it. So that's what we do, but what does this actually mean? What is the impact of taking this approach for users? So I think you're probably aware that there are a lot of unknowns, I think, associated with machine translation. How long is it going to take to get a system ready for me? How much is it going to cost? What do I need to do? And what will actually work for my content, and how well will it work? And I think what our approach does really is it helps to de-risk the machine translation proposition for people who are considering adopting the technology. I think the approach has the effect of reducing the impact of each of these factors. That's the time, the cost, the uncertainty over the whole process, and then overall risk. And I think this makes the adoption of machine translation much less of a daunting prospect for potential users. So an example of actually putting this ensemble approach with subject matter expertise together into practice for MT is our IP Translator offering, which is machine translation for patent, legal, and intellectual property content, which to our knowledge is the world's first and only, I guess, patent-specific machine translation system that's ready to go and use immediately. But what taking this approach also allows us to do is to deliver multi-purpose machine translation. So it's not necessarily just machine translation for the translation and localization industry, but it also has application areas across a variety of different industries and tasks. So I'll come back to these last two topics a little bit more later on. But first, let's go back and dive into the actual technology itself in a little more detail. So I think to explain this approach to machine translation, we need to first take a look at how most machine translation works today. And that is through a process that we call data engineering that is focused on collecting relevant training data for the language and content you're dealing with and putting this through a process to generate an MT system like you see here. So some training data comes in from the top. You have some input that goes through some pre-processing, through a machine translation engine, through some post-processing to build an MT system. And that's the process that existing vendors use. And when clients want to build a machine translation system, the process goes along the lines of, say they wanted an MT system for IT. They provide the machine translation vendor with training data, and this gets put through these processes for each language required. And the idea is that by putting in IT training data, then an IT machine translation system comes out at the end. And this is true to a certain extent, and this approach can give good results, but really only for, I guess, more simple, repetitive content types. If you're only dealing with a small vocabulary or things like websites or software where I guess the content isn't as complex. But I think the reality is that for highly technical domains and highly technical content types, that this approach simply doesn't cut the mustard, because when we're translating highly technical content, there are often very specific nuances in terminology and other things that need to be especially accounted for, things that a generic process simply can't capture. And I think a good example of this is patent documents, one of our areas of speciality. Patents are what we call a machine translation nightmare. They're so full of complexities and technical nuances across languages that there's no way in that we can have a simple process for just developing an off-the-shelf machine translation system. If you look at the example on your screen here, what we have on the right-hand side is a page from a patent document. What's highlighted there in blue is one single sentence. So that's going to be hard enough to read, never mind to translate, never mind to try and develop a machine translation system to translate. And we also have highly technical constructions like chemical formula, chemical names, amino acid sequences. And these are all things that are very difficult for machine translation. And the way that these sequences need to be translated is going to differ whether we're translating it from English into Chinese, into Japanese, into German. Things are going to be represented in a different way. So we need to treat these things specially across different language. So we need to learn all of the requirements and implement specific processes to handle them. So I guess just looking again at some of our experiences in doing patent machine translation over the last number of years, for example, the longest sentence that we ever translated had nearly 1,500 words in it, and the largest single document we translated had nearly 250,000 words. So that's what we're dealing with here, and that's what poses a real challenge for machine translation when we're looking at very technical content types. Which, going back to this data engineering approach, is why the focus on the training data alone simply doesn't work for technical content. It doesn't, and it can't take into account the nuances of the content and specific complexities, because this training step needs to be applicable for whatever the user's asking for. So I think we need to take a different approach, and that's what we've done here at Iconic. So the very first thing that we've done is we've gotten rid of the concept of a central machine translation system, so statistical or hybrid or whatever. Yes, we have some training data, and we are going to have some input, and we're going to have some output, and we're going to have some processes. But there's a much longer journey there that involves data engineering plus engineering of the language and the content. And this is what we call linguistic engineering in the ensemble architecture. So the ensemble can comprise many different steps depending on the language and the content in question. So for example, we might have some rules for Chinese pre-ordering. Or for pharmaceutical documents, we might have a tokenizer that identifies and tokenizes Korean input. We might have a process that identifies medical device names for Spanish. We might have a classifier on top of all that that for a particular patent document identifies the domain and subdomains that we're dealing with. So that's an example of some of the pre-processes we could have at the start. And then at the center of it all, we could have a tool like Moses that does statistical machine translation, but not necessarily just that. We could also have a rule-based machine translation system and have a grammar for a particular language pair. Again, it depends on what works best. And in many cases, maybe a mix of both works best. So we can do combination of both rule-based and statistical machine translation, depending on the input. And that could be for a given document, we either use statistical or rule-based, or we could even mix that. So within a single document, we could translate some sentences with a rule-based system, some sentences with a statistical system. And even going one step deeper, within a single sentence, perhaps we can combine statistical machine translation to translate some parts of the sentence and rules to translate other parts of the sentence. It really depends on what works best for a particular language and content type. Then after that, we can have more processes. For example, we can have some statistical processes that tries to fix some of the output in the machine translation system by learning the types of errors that it's making. Then we can have other processes that are specific to languages in particular. So for Japanese, we might have a process for normalizing the Japanese writing script, or for German, we might have some rules to compound certain sets of nouns. And then, when we're looking at tools like Moses and things like statistical machine translation and rule-based machine translation, these can fit in at any stage within this ensemble architecture. So for example, we could have a Moses system before the actual translation that does something like the pre-ordering, or we could have it at the end to do, for example, recasing or this script normalization. And I think combining these factors is the real delicate balance here, because sometimes the smallest change can have a big effect on things, but then at other times, having a big change can have no effect, particularly when we're talking around training data, where if you're not using relevant training data, you can use as much of it as you want, but it's not really going to have much of an impact. So it's really sensitive here. And I think this presents a big challenge, when we're taking the approach to machine translation, whereby, we have a new set of training data each time. And I think that arises particularly, as is often the case, when the machine translation vendor will be asked by a client, can you use particular terminology? And having kind of delicately seen what this balance is going to be between the cogs and the ensemble, we have to ask ourselves the question, where do we slot this terminology in? Do we at the start say, always translate this word like this? Or at the end of the whole translation process, do we then stick these words back in? So this is a real challenge. And I think the unpredictability of the whole machine translation process is something that I'll come back to a little bit later on. But I think taking this ensemble architecture approach and learning the best path through these cogs for a particular language and content type is what really can give machine translation an advantage in terms of highly technical content types. And ultimately, what taking this approach does is it gives us machine translation systems with subject matter expertise. And I think this is a crucial point here, because I think it's the same as if you're hiring a linguist to carry out translation. If the linguist needs to have the technical subject matter expertise. Otherwise, how can they actually understand what they're translating? And the same, I think, applies for machine translation. If you don't understand it, you can't translate it. So, if you look at this example up here, this is in English. I speak English myself. I speak some foreign languages, but I would in no way be confident that I could translate that into any of the languages that I speak, even with the help of dictionaries, because I simply don't understand what it means. So we have to impart that subject matter expertise onto the machine translation systems as well. And that's what we've done with IP Translator. These systems have been developed and implemented with this subject matter expertise because they have been developed with and evaluated by and are used by people who work in the area. So people who've guided us, our expertise as machine translation developers, our development has been guided by people in this area. And you see the example there with IP Translator. We've been working with patent information specialists to actually develop these types of machine translation systems. So that's a little bit about the technology. But if we talk about where is the actual value in taking this approach for users, I think an analogy I like to use is if you're food shopping. So, for example, if you need to buy some fruit, if you want to buy some apples, for example, yes, you can go to a general convenience style store like Walmart or Tesco's or wherever it may be where you are, and you can buy some apples there. And sometimes you might get some good apples, sometimes you might get some bad apples. It really depends. But you can nearly be guaranteed that if you go to a specialist provider of fruit and vegetables, you're going to get good quality, fresh apples. And I think the same applies for machine translation. Going for a specialist solution will deliver you essentially a better outcome. And what that means for the end user is more usable machine translation. And I guess the definition of usability really depends on what the ultimate end use of the machine translation is. So, for example, if you're using machine translation for post-editing, the process whereby you're essentially using the machine translation as a first draft and then modifying the output to bring it up to professional standard quality, using a specialist solution will give you increased productivity. If you're using machine translation for information purposes, taking this approach allows you to extract more meaning from the machine translation output. And if you're using machine translation for something like multilingual search or for translation of keywords, it'll allow you to retrieve more relevant results. I think obviously one of the issues in adopting machine translation technology is the inherent risk that's involved, because you're going to invest in this technology program and maybe it doesn't deliver straight away. It might start to bring you returns, but when are you going to see these returns? How long is it going to take, if ever? And some of the typical prerequisites for adopting machine translation will be that you're going to need to provide data to the machine translation vendor. You're going to have to wait some time for the initial development and evaluations, and then ongoing iterations until it gets to the point where you need it to be. And then there's going to be some cost associated with it. But we don't actually know what any of this is up front. So there's a massive risk involved in taking this. But I think the approach that we've taken developing these machine translation systems with subject matter expertise is that it really helps to de-risk the adoption of machine translation, because the prerequisites for using iconic translation machines, for example, is that there's no data needed up front, because we've gone to this effort of collecting our own data and developing these systems. So the systems are actually ready to go and evaluate immediately with no upfront cost. And even then, while those systems are there and they're ready to go up front, they again can serve as the starting point for ongoing customization and refinement for specific use cases if needs be. And this can be done in a number of ways. So, for example, some of the ways that we've done it to date is, number one, through the incorporation of user feedback, where people who are actually consuming the machine translation, be it the people who are reading it or the translators who are post-editing it, can provide us feedback on the types of errors that are occurring in the machine translation output, so that we can focus our future development efforts on fixing those mistakes. We can also do incremental training with post-edits, and what that means is that we get visibility from our users on the type of edits they're making to the machine translation output to bring it up to full human quality, so that then we can go on and automatically learn how to fix those mistakes in future. And then we can do things like slightly tuning the machine translation systems that we already have for specific input types. So if you look at our IP Translator system, where we've developed it for translating patents, and that would predominantly be patent applications, already granted patents. But in one example of a project we had to translate search reports, written opinions on patents. So there was a slightly different style of language use. So we're able to take a small amount of training data and adapt the core systems that we have to actually translate these types of reports. So I think what I want to look at next is, so that's a little bit about the technology, and I think the value that it can bring to its end users. So I want to now look at the who, the what, and the how. So firstly, who uses IP Translator and iconic translation machines. And I think having a domain-specific and industry-specific solution like this not only allows us to serve the traditional translation and localization industries, but it also opens up use cases in the specific domain or industry itself. But firstly, looking in the localization industry with IP Translator, typical users would be larger language service providers who operate across multiple verticals or industries and maybe looking at different machine translation solutions in each of these. So there you have companies, for example, like Relocalize or TransPerfect. But then we also have specialist language service providers who kind of like single language vendors who focus on a particular language. These companies will focus on specific industries. So they're more like single industry vendors. And an example of this in the patent industry would be companies like RWS. But outside of that, there are other potential users of machine translation within the application industry itself. These will vary across the different industries, but for example, again, in patents and intellectual property, there are other use cases for machine translation amongst patent search providers like the European Patent Office and other commercial providers of patent search like Thomson Innovation. Then there are organizations who provide data to these groups like WIPO, the World Intellectual Property Organization, and LexisNexis. We then have multinationals who have in-house patent search groups, and they're IP active, and this is particularly common for chemical and pharmaceutical groups like Abbott. And then there's also use cases for law firms as the end user client as well. So what exactly do these types of companies use Iconic and IP Translator for? So if we're looking at language service providers, there's a case here of not all translations needing to be the same. The quality requirements aren't necessarily the same with all language, with all translation jobs. So what language service providers can use machine translation for is to offer a variety of different translation services to their end clients, depending on the use case. So if I talk about post-editing, you can have the process of full post-editing where the machine translation output is brought up to perfect, legally watertight human translation quality. And that's obviously required for something like if you're translating a patent to file it somewhere. But that's not always the case. And sometimes light post-editing is fine if the document is going to be circulated internally for reference purposes, something like that. Maybe just editing of larger grammatical errors, but not worrying too much about kind of punctuation or things like that, then that can be offered as a lower cost service as well. But sometimes the unedited machine translation output itself is sufficient. For example, if you need to determine whether or not it is worthwhile investing in a full human translation for a document, because oftentimes it's not relevant or it's not required. And an example of this could be for e-discovery type jobs where you can often have massive volumes of content that need to be turned around in a short space of time. So often here human translation isn't practical, and this is something where machine translation has a very unique and very specific use case. And then if we look at patent search and data providers, they can also use machine translation in a number of different ways, I guess, depending on their strategy. And each of these approaches has its various pros and cons. But one thing patent search and data providers can do is do batch translations of their databases. So if they have a database of Japanese and Chinese and German patents, they can translate all of these millions of documents into English so that their users can search them in their own language. And this obviously adds a lot of value to their own services. Now, there are challenges in this in that, it can sometimes take a long time to translate many millions of documents, and the actual machine translation quality is then static. And if the machine translation system improves itself, then we'd have to retranslate. But this is quite a big use case in this area. And the alternative to this approach is on-the-fly translation of patent search results in combination with query translation. So actually, rather than batch translating the entire database, you can allow the user to retrieve these foreign language documents by translating the queries, and then when they actually retrieve a document that's in a foreign language, using machine translation on demand to translate that. And then on top of that, the multinationals and law firms, they can typically use machine translation as mainly to I guess to save money by not having to outsource jobs that really only need to be used for gisting. So during patent searches, patentability searches, freedom to operate, or infringement searches. Sometimes just translation is all that's required, but a law firm or a multinational might always outsource this for human translation when that's exactly what they don't need. So oftentimes machine translation can be taken in-house to support this process. And then if we look at the how of Iconic translation machines and IP Translator, how can these companies actually use our services? There are a number of ways they can do this to connect to the service and retrieve translation. Principally, this is done through our Iconic API, which allows for more programmatic connection to a translation management system to integrate machine translation more deeply into a project management workflow. But we also have connectors and plugins developed for computer-assisted translation tools like SDL Trados 2011, 2014, and MemoQ, which, as opposed to the batch translation, allows you to kind of do on-the-fly translation of individual segments. We also have a simple online portal that allows users to upload and download translated files, and this is kind of ideal for lower volumes where full API integration isn't really required. And this approach is actually quite well suited for just MT, where you just need to get a document translated for circulation for information purposes. So what I'd like to do now is actually just look at a couple of examples of how Iconic has been put into practice using the techniques that we've described already. So one of these is with one of our clients, WeLocalize, who are a large language service provider who have a multi-machine translation vendor policy, whereby they basically use the best machine translation solution for whichever area they're working in. So their business need was that they needed machine translation technology for the legal industry. They have machine translation for other verticals. They entered the legal industry and they needed a machine translation solution. And we obviously had this solution already developed with IP Translator. So there was a natural fit there to kind of explore what the possibilities were. So what this process looked like was that WeLocalize obviously wanted to see what the translation quality was like. So they provided us samples for us to translate for an initial evaluation. And the benefit of having our systems already built and ready to go was that we were able to deliver these translations back to them immediately. And the initial results here were positive. So the next step was then to actually see what sort of productivity the professional translators would get by post-editing this output. So the step to do this was to integrate Iconic with their global site translation management platform, which they're able to do relatively simply and painlessly through the API that we've developed. And then once they've done that, they're able to actually evaluate their performance in production. And what we were able to do was deliver measurable productivity gains from the outset, whereby translators were translating documents over 20% faster by post-editing the output from our machine translation systems. And that's post-editing the output of the systems that have already been built. There was no specific customization done for WeLocalize. These were the systems that were already built and ready to go, and they were already seeing more than 20% productivity gain off the bat using these systems. So kind of looking at where our engagement with WeLocalize is at now and where we're going in the future. So obviously the systems are being used on a daily basis, and we've translated more than 4 million words to date for Asian languages. And we're doing a periodic rollout now of new languages over time as they come on stream in WeLocalize. And we have two strands of how we're doing ongoing improvements of our systems so that we can constantly increase that the productivity delta that they're actually getting by post-editing machine translation. And that's firstly through feedback from the translators. So on a fairly regular basis, their translators will provide us feedback forms on the types of errors that they'd seen, how grave these errors are, or how much these errors held them back, so that we can focus on tackling those issues and those errors that will allow the translators to become even more productive. And then over time, as the translators are post-editing these documents, we get visibility on these documents so that we can start to automatically learn how to improve the systems. And again, continue to increase the productivity that the translators are getting. If we look at another use case in one of the other application areas that I mentioned, we worked with the European Patent Office a while back, and their need was that they had a very specific need for a short-term solution to provide on-demand machine translation through their web search interface. So they provide a search interface for their end users, and they needed a machine translation system to translate the search results. So the process here was that they integrated again directly through our Iconic API and evaluated the quality firstly, but also the throughput. So, I mean, these are translations that have to be returned immediately because the search user doesn't want to have to be waiting around for 20, 30 seconds for a machine translation to come back. So they also were testing the speed of the system. And the outcome of this project was that in 5 months of production for English to Portuguese machine translation alone, we processed over 15,000 translation requests and translated 14.6 million words. So that's around 100 requests per day that we were processing. And the only way that we could actually do this was by having a machine translation system that was built and ready to go. So there are a couple of examples of how we've engaged with clients on this type of machine translation to date. But looking forward as to kind of where we're going with Iconic and what we want to do, I think our main focus is to bring machine translation with subject matter expertise to a wider range of areas. So in the first instance, we're going to focus on developing systems for new domains, for new high-value technical vertical markets where we'll be able to develop new MT systems with subject matter expertise and expand this ensemble architecture that we have. And then to date, we've focused on I guess, a set of core languages that were of particular importance within patents and legal translation. What we also want to do is start to expand the language coverage of our systems. So in terms of domains, we're going to be looking at life sciences, pharmaceutical, medical devices, areas that are often quite similar to patents in terms of the technical nature of the content. So our technology will actually lend itself quite well. And then, as I mentioned, we're kind of looking at, so to date we've focused on languages of specific importance, but now we're looking at, I guess, more emerging languages. So languages maybe where the demand isn't massive today, but that we can see coming soon down the line, there's going to be an increasing demand for translation. So those languages include languages like Russian, Arabic, and Turkish. So just to wrap up, I want to give you some maybe, I guess, take-home messages and some of the lessons that we've learned over the last number of years in taking this approach to machine translation. The first one, to modify a well-known phrase, is that all content is not created equal. And as such, the entire translation process and consequently the machine translation process needs to be different for different languages and different types of content. And in developing this technology, we can't afford to be dogmatic when it comes to the type of machine translation that we're using, because one size simply doesn't fit all here. If we're practitioners of statistical machine translation, we're restricting ourselves to what it's good at. And even if we're hybrid, trying to combine rules and statistical machine translation, we're still restricting ourselves. We need to be able to use whatever works best for a particular language and content type. And when we're developing machine translation for specific domains, we need to be aware that developing domain-specific machine translation is about more than just the data. Yes, a sufficient amount of good quality, clean training data is obviously a key component in the training process, especially for statistical machine translation, but it's not everything. So to go back to a food analogy like I used previously, I think the data to machine translation training is similar to the ingredients to a chef. The chef still needs to know what to do with the ingredients to produce the final meal at the end, and the same with the training data. The machine translation processes need to know what to do with that data, need to know what data that is, what content it is, what language, what style, so that it can develop a specific process. And I guess the final point that I alluded to earlier on with the training data, so you need to know what your training data is, and you need to know your subject matter, because you could have the most refined approach to developing a machine translation system, but data will be the biggest variable to quality. So our approach that we've taken with the ensemble, with pre-building these machine translation systems, allows us to deliver high quality out of the box, which we can then refine, as opposed to what is kind of a great unknown of training from scratch each time we want to build ourselves a new machine translation system. So I'll conclude at this point. If you have any questions, I'd be more than happy to take them. We can do some Q&A for a few minutes if people have questions. If you want to type them in the box, might give you maybe 30 seconds or so there to type the questions into the box, and I'll come back to you then, and we can do that.